Yeah, if you write the division algorithm in other way, so let's do this one. We are dividing A with B and we are getting a quotient Q, and so B into Q we get some number, and if we subtract and we get a remainder. The relationship between these all things what we see here, to get the A we do B multiplied by Q, then add the remainder, and we have seen this R always be less than B, and this will be always greater than 0. This is what division algorithm. There is nothing. So how you have to do this one? Closest one. That's the only rule. Then you will get automatically this one, and there is only one pair to satisfy. One pair of Q and R will satisfy this condition. That's all about division algorithm. Let's see what is our the problem 3 that initially we discussed. So the question what we got is 6q plus 1, 6q plus 3, 6q plus 5. If we put q is any positive, q is some integer. So q is some integer means it will go from 0, 1, 2, 3, 4, etc. So that is nothing but q belongs to whole numbers. I don't know what is the term, what is the letter which we represent. I think W. Okay, it's a whole number. So we have to prove that these will represent odd number. So we already proved by replacing q with 0, 1, 2, 3, and we got all the odd numbers 1, 3, 5, 7, 9, 11, etc. We already proved with a different way. Now with the division theorem, how we have to prove? Okay. So let's take how we can write A equal to B plus BQ plus R, right? So let's take B as 6. Then when we take B as 6, A equal to 6Q plus R. So according to the division theorem, R is always less than or equal to B and greater than 0. So here B is 6. R can be 0 up to 6, but not 6. So that means R will be, what are the values R can take? It could be 0, 1, 2, 3, 4 and a 5. So if we do any positive integer A, how we can represent? A equal to 6q plus 0, that is 6q, or it could be 6q plus 1, or it is 6q plus 2, 6q plus 3, 6q plus 4 and a 6q plus 5. Any integer we can in the form of this one only. So let's see more about that one. So I will erase this one. So any positive integer I can go with 6q, 6q plus 1, 6q plus 2, 6q plus 3, 6q plus 4, 6q plus 5. So if I put 0 everywhere, it will give 1, 2, 0, 1, 2, 3, 4, 5. If I put 1, I will get 6, 7, 8, 9, 10, 11. So any integer, if I go with dividing with 6, it will be in the form this one. Okay, nice. Okay, if we look at this one, in this one it will be 2 of 3q, and if I write this one, if I take 2, 3q plus 1, if I take this one, 2 of 3q plus 2. So when something is multiplied by 2, it's always like an even number, isn't it? So when I cut these things out of this one, then these are representing even numbers. So this set represents all natural numbers. If I cut even numbers out of it, then remaining will represent the what? Odd numbers. What is left? 6q plus 1, 6q plus 3, 6q plus 5. I try to write whole numbers using the divide. When I divide it with 6, this is the one represents all numbers. In that one, I eliminated which represents even number. How I removed? Because these are multiplied by, I can write it in this way. Why can't I write this one? If I put 2, 3q plus 1 by 2. But I want an integer, not a rational number here. You will see that point. I can't write this one like this. So I took in whole numbers, I cut the even numbers. The remaining numbers represents odd numbers. What are they? 6q plus 1, 6q plus 3, 6q plus 5. Hence, these represents odd numbers, any odd number. So, any confusion?